Welcome to the ELM Test Prep Series by James S. I'm going to take a look at equations involving fractions. And specifically we're going to look at rational fractions, and that means a fraction with a letter, or a rational polynomial as they might be called. So if I had 3 over a equals 2 over, we'll just say b. We'll just start off simple here. I just want to explain one thing. First of all, you cannot divide by 0. You cannot divide by 0. Just fix that in your mind when you're dealing with rational polynomials and fractions. You cannot divide by 0. Alright, so we've covered that rule. So what does that mean to me in terms of solution? Well, in terms of this particular problem, a cannot equal 0 and b cannot equal 0. So any value or solution to this that would put as 0 for a or b would be invalid. Alright, so let's look at what we can do here. I can multiply, and I want to get rid of the fraction here, so I'm going to multiply both sides by a and I'm going to multiply both sides by b. Over here, the a will cancel the a, because a over a is just 1, and I'll be left with 3b over on this side. Over here, the b's will cancel, leaving me with 2a. Okay, that is essentially what we are doing. We are doing the same thing to both sides, and by doing that, we then remove our denominators. It's no longer a problem involving fractions. Let's look at another way of thinking about this. Well, I could simply say this term crosses over and multiplies over here. And this term crosses over and multiplies over here, leaving me with 2b equals 3a. Well, remember we said that if I multiply both sides by b, b's go away. Well, that is essentially, I brought the b over here. This side by b, this side by b. I multiply both sides by a, and I essentially brought the a over to this side, and these were eliminated over here. So I can essentially solve a rational equation by taking my denominator to the other side as a multiplier. Alright, so let's look at something that's a little more complicated. Yeah, we'll go with that. Alright, so let's look at our denominator first of all. A cannot equal, well, it cannot equal 0, because if I put 0 in for a, I'd be division by 0. So it cannot equal a. And if a were a 1 here, 1 minus 1 would be 0. So that a cannot equal 1. So if those two answers were in my group of answers, I would throw those out. I'm not even going to look at those because they both cause division by 0. So let's look at solving for a. Well, again, I'm going to cross multiply my terms up to the numerators. Get this out of my way. A cannot equal 0 or 1. Okay, so I'm going to multiply this up here, a minus 1 times that, and the a over there, and so my denominators are now gone. I took the a over here and I took the a minus 1 over there. So now my equation is 2a equals 3 times a minus 1. I'm just going to distribute this times both terms, and that's going to give me 3a minus 3. Alright, so now my equation is 2a equals 3a minus 1. I'm sorry, minus 3. Need to pay attention here. Okay, so I need to get all my a's on one side and all my numbers on the other, because I'm looking for the value of a. Alright, so I'm going to subtract 3 from both sides here. Minus 3a and minus 3a. I did the same to both sides. 3a take away 3 is 0, so I'm just left with a minus 3 on the right side. And 2a take away 3a leaves me a minus a on the left side. Alright, so now I'm going to multiply both sides, or divide, doesn't matter, by a minus 1. Minus times a minus is a plus. Minus times a minus is a plus 3. So my answer for A is plus 3. Well, it is not a 0 and it is not a 1, because that was not a valid answer for A, so at least it is a possible valid answer. Alright, we're going to look at a little more complicated problem. 4 over 2x minus 2 equals 1 over x plus 1. And again, we're going to use this concept of taking the denominator to the other side, cross multiply. So I'm going to end up with 4 times x plus 1 over here, and 1 times 2x minus 2. Well, let's look at what our x cannot be. X cannot equal, well, cannot equal 1, minus 1, because that would make that 0. So minus 1 is one of the valid or invalid answers. If I put a plus 1 over here, 2 times 1 would be 2, and 2 take away 2 would be 0. So plus 1 is also not a valid answer. So having decided that, I am then going to continue on. So 4 times x is 4x. 4 times 1 is 4. Equals 1 times that, which is 2x minus 2. All right. What we're going to look at is getting all the x's on one side. So I'm going to subtract the 2x from this side, and I'm going to subtract 4 from this side, and I'm also going to subtract 4 from this side and subtract 2x from this side. I've subtracted 2x from both sides. This goes to 0. 4 minus 4 goes to 0. 4x take away 2x is 2x equals minus 2 minus 4. They're the same sign, add their value, and keep the sign of the larger. All right, minus 6. Then I'm going to divide both sides by 2 and get a final answer of x equals minus 3. And it is not any of the invalid answers, so we're good to go. Well, we're pushing the clock here. And what we were looking at is what we can do with solving rational polynomials or equations with fractions in them. Hope this was useful. This is something you want to practice a few times. Be comfortable with the reasons why you can cross multiply the denominators. and then solve your equation. All right. Have a good day.